Namaste and a very good morning to one and all present here. Today is 5th of January 2021 અને ગુજરાતી કેલેન્ડર પ્રમાણે આજે માગસર વદ સાતમ છે. I am Siddharth Shah of class IB2. We will begin today's assembly with prayers. Please get ready for prayers.
हे शारदे माँ शारदे, हे शारदे माँ शारदे, अज्ञानता से हमें तार दे, अज्ञानता से हमें तार दे। हे शारदे माँ शारदे, हे शारदे माँ शारदे। तू स्वर की देवी संगीत तुझसे, तू स्वर की देवी संगीत तुझसे, हर शब्द तेरा हर गीत तुझसे, हर शब्द तेरा हर गीत तुझसे। हम भी तो समझे, हम भी तो जाने, हम भी तो समझे, हम भी तो जाने, शिक्षा का हमारा अधिकार दे। हे शारदे माँ शारदे, हे शारदे माँ शारदे, अज्ञानता से हमें तार दे, अज्ञानता से हमें तार दे। हे शारदे माँ शारदे, हे शारदे माँ शारदे। गुनियों ने समझी, मुनियों ने जानी, गुनियों ने समझी, मुनियों ने जानी, वेदों की भाषा पुराणों की बानी, वेदों की भाषा पुराणों की बानी। हम हैं अकेले, हम हैं अधूरे, हम हैं अकेले, हम हैं अधूरे, तेरे शरण में हमें तार दे। हे शारदे माँ शारदे, हे शारदे माँ शारदे, अज्ञानता से हमें तार दे, अज्ञानता से हमें तार दे। हम हमें तार दे, हमें तार दे, हमें तार दे, हमें तार दे।
Henry Poincaré once said, mathematics is the art of giving same name to different things. Our assembly's theme is how mathematics is connected to different art forms like music, dance, and painting. I would like to invite Sarangi of IG2 to present how mathematics and guitar are connected.
Namaste. Today I will be talking about how guitar is related to maths. There are many applications of maths and guitar. So let's start from the basic, the frets and the strings. So what are frets and strings in guitar? So these are known as frets. So the frets are counted in numbers like 1, 2, 3, 4 and so on. In this guitar there are total 22 frets. Likewise the strings. So there are 6 strings in the guitar which are counted from the bottom. So the bottommost string of the guitar is counted as 1, then 2, 3, 4, 5 and the topmost string is counted as 6. The next factor is the frequency. So the frequency of the sound is inversely proportional to the length of the string. So now if I play the first fret of the first string in guitar, the frequency will be a lower. Now if I play the 6th fret of the same string, I'll get a higher frequency. One more fact about the frequency of the sound in guitar is that by playing the 12th fret of guitar, we get a frequency which is double. The next point is the pitch. The pitch of the guitar is related to the thickness of the string. So the first string in the guitar is the thinnest, while the 6th string is the thickest in guitar. So if I play the 6th string in guitar, the pitch will be lower. Now if I play the first fret in the 6th string, the pitch will be a little higher. Now let's talk about Pythagoras theorem in guitar. So Pythagoras was a Greek mathematician who is famous for his mathematical analysis of the length of the sides of the right angle triangle. So he said that the pitch of the sound is inversely proportional to the length of the string. So now if I play the first fret in the first string, the pitch will be higher. Now if I play the 6th fret in the same string, the pitch will be lower. Next, he said that by playing the half string, which is the 12th fret, so 12th fret in the guitar makes the string half. So by playing the 12th fret in guitar, it creates the same note but in higher octave. So Pythagoras ratios of guitar frets is nothing but the relationship between the strings and the frets of guitar. There are two methods for obtaining the Pythagoras ratios. The first one is the traditional method known as rule of 18. It was used by the guitar makers many years ago. In this method, we have to divide the string length, which is from the nut till the bridge. We have to divide it by 17.817. So some of you might want to know that why only 17.817. So 17.817 is one of the most accurate numbers till now, which divides the string in the ratios of 1/18. So first, the whole string is divided into 18 parts, which makes the first fret. Now again, the remaining string is divided into 18 parts, so the first part makes the second fret. So you all might have noticed that the first two frets have a bigger distance between them, while the last two frets have very less distance between them. So the reason is that the frets and the strings are divided in 1/18th fraction. The second method is a mathematical formula which says distance x is equal to s divided by 2 raised to x divided by 12. So here x is the number of frets being evaluated. So if we want to find the distance of the first 3 frets, we'll take x as 3. Distance is the string length from the nut to the bridge. S is the resting string length, so the string length after 3. And 12 is the number of frets or notes per octave. So these are some of the basic applications of maths and guitar. Thank you.
Thank you, Sarangi, for that wonderful presentation. Now I would like to invite Tanmay Jhala of IG2 to tell us how simple topics of mathematics like geometric progression counter for producing different sounds on piano.
Music and maths, so abstract and beautiful, and if you understand, so simple. Today I'll be talking about the relation between mathematics and keyboard. The first thing that came to mind was geometric progression. Geometric progression is basically a sequence or progression of numbers with a constant ratio between all the numbers. For example, 1, 3, 9, 27 and 81. You have to multiply each number by 3 to get the next value and to divide by 3 to get the previous value. On keyboard, this also applies. The value of C#0's frequency is 17.35 Hz and the value of C0 is 16.35 Hz. Now, if you divide 17.32 and 16.35, you get 1.06. Same way, now you have to multiply the key by 1.06 to get the value of the frequency of the next note. As you can see in the formula, there are 3 variables A, R and N, where A is the frequency of C0, 16.35 Hz. R is the common ratio that we derived before, 1.06. N is any key on the keyboard. So it can be this, it can be this, and it can be this, any key. So now, if you want to find the frequency of any of those keys, just find its position with relation to C0 and then substitute that value as N and calculate using the formula. Another thing I noticed is exponential rule, which is 2, 4, 8, 16, basically 2 raised to N. The frequency of C0 is 16.35 Hz. The note 1 octave ahead of it, C1, that's 32.7 Hz. And another octave ahead of it, C2, that is 65.41 Hz. They all are multiplied by 2 to get the value of the octave ahead of it. Interestingly, for every 3 white keys, there are 2 black keys. 2 by 3 is 0.6. For every 5 white keys, there are 3 black keys. And 3 by 5 is 0.6. Per octave or 8 white keys, there are 5 black keys. 5 by 8 is again 0.6. So, we can say that the ratio between black and white keys or on any keyboard or piano will always be 0.6.
Thank you, Tanmay. That was an interesting presentation. Shubham Donga of class IB2 will be discussing an interesting concept of golden ratio in painting.
Once a great Greek philosopher said, "Wherever there is number, there is beauty." So, hello guys, I would like to talk about golden ratio today. So, what exactly is golden ratio? During the olden era of Renaissance, renowned artists and architects used an equation known as the golden ratio. Some of the famous artists like Leonardo da Vinci used this mathematical concept in his famous paintings like Mona Lisa. Golden beauty ratio is approximately 1.618. Researchers have found that the human perception of physical beauty goes hand in hand with the mathematical golden ratio. So, putting it into the simpler words, it is the distance between certain regions, the face, to the distance of another defined region, which should be closer to 1.618, then it's considered ideal. So here are some of the ways for calculating the golden ratio. The distance from the top of the nose to the center of the lips should be ideally 1.618 times the distance from the center of the lips to the chin. Secondly, the hairline to the upper eyelid should be 1.618 times the length of the top of the upper eyebrow to the lower eyelid. If we consider the ideal ratio of the upper to lower lip should be 1 is to 1.6. Nowadays, we can use various platforms like Metrics or online websites for calculating the ratio easily and efficiently. So now I will be talking about some celebrities having an ideal face proportion. Images shown here are of an American model named Bella Hadid. She is considered world's most beautiful woman according to golden ratio. According to the ratios calculated in the second image, we can observe that she has facial features which are satisfying the ratio of 1 is to 1.618. Considering this second image, we can observe that the distance from our inner cheek to outer cheek is 1.618, then the distance from the lower lip to the chin is 1, the distance of our eyelids are 1, etc. So these are all the distances and ratios which satisfy the golden ratio. The distance can be easily calculated with the rule or caliper. Face may not perfectly match to the ratios, but it's almost similar to it. Continuing, images shown here are of a British actor, singer, and songwriter named Harry Styles. In the second image, we got ratios by measuring eye widths, nose widths, etc. We can observe here that these measurements almost satisfy the ratio of 1 is to 1.68. Looking at the second image, we can see eye widths are 1, the ratio from his nose to the outer cheek is 1.618, the ratio of upper lip to the chin is 1.618, and his lips width is approximately 1.6. So he's having almost perfect face features, including his nose, eyes, and jawline.
Thank you, Shubham. It was an amazing connection between maths and beauty. Can you ever wonder how mathematics can help us dance? To answer this question, I would like to invite Takshi Mehta of class IB2 to throw some light on it.
Bharatanatyam is a highly schematized Asian Indian classical dance that integrates nuanced body movements with Carnatic music. The integration between mathematics and Bharatanatyam isn't that unknown. However, the knowledge is brief. I am Takshi and I'll be explaining the basic connection between maths and Bharatanatyam. Let's begin with Carnatic music, the foundation of Bharatanatyam. In Carnatic music, the rhythmical structure of composition is made up of patterns called talas. A repeated cycle of tal consists of a number of equally spaced beats, which are grouped into combinations of three patterns. The patterns are Laghu, Drut, and Anudrut. You might have seen dancers have gestures that keep track of time, such as Tai Ya, Tai Hi, Tai Ya, Tai Hi. This is basically a way to keep track of the beats. Drut is 2 beats, Anudrut is 1 beat, and Laghu is a pattern of 3, 4, 5, 7, and 9. There are 7 families of tals that are in arrangement that depend on the arrangement of patterns. According to the beats of Laghu, there are 5 jatis. Together, they form 35 tals that are used in Bharatanatyam. Let's move on to geometry, symmetry, and trigonometry. The first and basic position in any dance of Bharatanatyam is the Aramandi. The Aramandi is the legs position, which is like this, where both the heels touch each other and form a 180-degree angle, and the toes point outwards. Next is the hand movement, which is a Natya Rambe. The angle has to be 45 degrees when it comes to the Natya Rambe. So the elbow is always supposed to be bent at 45 degrees and not 90 or 180. Always 45 degrees. While doing any action or adus which goes like this or this, the line of symmetry shouldn't change. Therefore, the shoulder can't come in the front but always has to stay in the back. And therefore, when doing a step like this, the shoulder always stays here. Therefore, maintaining a balance even in the feet. Okay, now I'll be talking about the basic adavas, which is the basic actions of the dance, the foundation of the dance, and the use of angles and lines in that. So for the first example, we're going to take a basic action, which is this. Okay, so in this step, both the hands have to form a straight line at 180 degree. So this has to be one straight line, and it can't be this hand can't be bent or this hand can't be in the front. It always has to be here. Okay, it's also important that this hand, the lower hand, and the leg that's going out they form a parallel line. So it's important that this leg, the one that's bent, is at a 180 degree pointing outwards here, and this leg is going out is at parallel with this, the lower hand, and this hand is at a straight line at this hand. So therefore, maintaining a certain kind of symmetry of the body, and the balance maintains. Another basic action is the jati movements, which is there are 3 types of jatis. The first one goes in the front, which is this. The second goes diagonal, which is this, and the third is this. Okay, so it's very important that these 3 steps are differentiated from each other and not look the same. For the first one, it's important that this hands and legs both go at a 90 degree and not even slightly this way or that way. For the next, it has to be at 45 degree. And the last one has to be at 180 degree. If the angles are not maintained, then the step can go wayward and they don't look different from each other. And they look the same, which changes the whole symbolism and the structure of the kriti, which is the whole dance performance altogether. So that is it between the correlation between dance and Bharatanatyam. Those are the basics of it. There can be a greater use of maths in dance if one wishes to, but the actions and the examples that I demonstrated are some of the things that are internalized in the dancer without their knowledge that they're using maths in dance. Bharatanatyam is a very rigid and organized form of dance, unlike many of the other dance forms, which are generally fluid and they're very, very malleable. But Bharatanatyam is very organized and very rigid, so it's important that there's certain use of maths and precision in the dance. So, yes, thank you.
Thank you, Takshi, for giving some insight on connection between dance and math. Today's point to Socho will be presented by Siddhi Changela of class IB2.
Today's point to Socho is that mathematics is the cradle of all creations. Maths is the methodical application of matter. It is so said because the subject makes a man and his actions systematic, making our lives orderly. Mathematics nurtures every single thing that we do, day in and day out, knowingly or unknowingly. Be it as a dancer or as a musician, be it as a painter or a magician, everyone needs mathematics to live. We are entirely encompassed with the numbers and their applications. Despite us being unaware of how frequently we make use of mathematics in all the activities we do, we have been embracing its beauty ever since we have begun our lives. It is a form of expression that gives us every reason to hope that every problem that we face has a solution. After all, it is rightly said pure mathematics is in its way the poetry of logical ideas. Thank you.
Thank you, Siddhi. Thank you everyone for being a wonderful audience and have a wonderful Tuesday ahead.